Hey guys, Ms. Zarnowski here. Going to walk you through how to do questions like R3 and R4 on your skills check 7.3, 7.4. I'm going to work through both of them together because they're very similar in style, and chances are if you got 7.3 wrong or didn't know how to do it, you probably didn't know how to do 7.4 either. So the setup and the method to solving is going to be the same. R4 just takes it an extra step. So the question is, can you find the factors and the roots of a polynomial given a factor or a root? And the way we have to solve this problem is by using synthetic division. So you always use synthetic division with the solution, or the zero. So if you're given the factor, you have to find the zero. So for x plus 3, the zero would be negative 3. If you were given that the root, or the zero, is negative 3, that's what you're actually going to use. So we're going to set up our synthetic division with the negative 3 out front. Our coefficients are 5, 2, negative 33, and 18. And what we do is we bring down the leading coefficient 5, multiply up. 5 times negative 3 is negative 15. Add to come down. So 2 plus negative 15 is negative 13. Multiply up. Negative 13 times negative 3 is positive 39. Add to come down. Negative 33 plus 39 is 6. Multiply up. 6 times negative 3 is negative 18. And add to come down. 18 plus negative 18 is 0. Now remember, that last number on the end is your remainder. And you have to think, does it make sense that we would get a remainder of 0? Well, the answer is yes. In fact, they've already told us that x plus 3 is a factor, or x equals negative 3 is a 0 of this polynomial, which means if you divide it, there shouldn't be anything left over. Okay? So, where are we at? We've got the factor they gave us, x plus 3, and now we have this next polynomial that we can use. So working our way up, we have the constant x to the first, x to the second. So we have 5x squared minus 13x plus 6. Well, in order to fully have this factored, we need to continue factoring the quadratic that we have. So the x plus 3 is good, but now I need this factored. How do we factor a quadratic? Well, since our leading coefficient is greater than 1, we can use the x in box method. So I'm going to set up my x. Remember, in the top of your x is product of a and c. So a times c is going to be 30x squared. In the bottom goes b. b is negative 13x. So we need to think of the factors of 30 that add up to negative 13. Those are negative 10 and negative 3. Okay? If you didn't think of that, you can make your list of factors. A lot of people would be tricked and want to use the 2 and 15 combination, but remember, we need a positive 30. So both factors either need to both be positive or both be negative. So we can do that with the negative 3 and 10. Okay? Then we go to the x, or the box. Inside the first box goes the first term, 5x squared. Last box, last term, 6. And then our other two boxes, we fill in our two factors, negative 10x and negative 6x. Negative 3x, sorry. Okay? From here, we have to factor out our greatest common factors of each row and each column. So, the biggest thing you can divide 5x squared and negative 10x by is 5x. Biggest thing you can divide negative 3 and 6 by is 3, and since the box closest to the outside is negative, you take the negative. Factoring up, biggest thing you can factor 5x squared and negative 3x is x. And the biggest thing you can factor out of negative 10x and 6 is 2. But again, since the box closest to the outside is negative, you take the negative. So that makes our other factors, in addition to the x plus 3, we have 5x minus 3 and x minus 2. Now, here is where you stop for R3. We've completely factored the polynomial. R4 gave you the root -3 and asks for the other roots. So, since you were given that root -3, you have to finish by finding the roots of the other two factors. So, you can set the 5x minus 3 equal to 0, add 3 to the other side, and then divide by 5. So you get x equals 3/5, and then here x would equal positive 2. So there's, in blue, all three of your roots. Okay, so you can see that for both R3 and R4 you approach the problems the same, but you just need to take it one extra step further for R4. Hope this helped.